There are different kinds of chemical equations. We can look at molecular equations, we can look at complete ionic equations, or net ionic equations. A molecular equation is what most people think of when they think of a chemical equation. We're going to show the neutral formulas for all the compounds that are reactants and products. So here, we've got KOH and MgNO3 Both of these are aqueous. And when an ionic compound dissolves in water, the ions actually separate from each other. So this is not really representing how those ions are in the solution, because it implies that they are together next to each other when they're not. And here, magnesium nitrate, those ions are also separate. Over here, potassium and nitrate, still soluble. Potassium and nitrate did not get into a relationship in this beaker. They're just still floating around, having fun at this party, right? But magnesium and hydroxide formed an insoluble compound. They precipitated to the back porch, and they're not in the party really anymore, right? So this is the molecular equation. In a complete ionic equation, we're going to look at all the species, that's all the parts, as they actually are present in the solution. So we would show KOH as potassium ions and hydroxide ions. And anything that's aqueous ionic, we're going to separate into the individual ions, because that's how they actually are. And then the net ionic equation, so this is like your gross paycheck and your net paycheck, right? Your net paycheck is always smaller because they took out taxes and all kinds of other stuff, right? So the net ionic equation is going to be smaller in a sense that we're not going to include any ions that didn't get involved. So we'll talk about that. It's only going to show the things that actually got into a relationship. So aqueous strong electrolytes will always be written as individual ions. And so these include soluble salts. And when a chemist says salt, they mean ionic compound. Soluble ionic compounds. Strong acids and strong bases. We'll talk about exactly what those are in a few minutes. Any insoluble substances, any weak electrolytes or non-electrolytes we'll write as molecules. So solids, liquids, and gases are not aqueous. They're not separated into ions. And so if you see solid, liquid, or aqueous as the phase or state symbol, you just write the whole molecule. Weak acids will be written with an AQ, but we have to understand that weak acids only ionize a little bit, and so we're going to represent what they mostly are, which is molecules. So here's this example with the lead nitrate and potassium chloride. It's forming solid lead chloride. So this is the molecular equation, and then to write the complete ionic equation, we're going to separate things into ions. And so this is an ionic compound that's soluble, this is an ionic compound that's soluble, and this is an ionic compound that's soluble. So when ionic compounds are soluble, they separate into their individual ions. So we're going to write them that way. PbNO3 this 2 tells me there are 2 nitrate ions. So I'm going to have 2 nitrate ions and 1 lead 2+ ion. Here I have 2 formula units of KCl, so I have 2 potassium ions and 2 chloride ions. This is a solid. It's not separated into ions in the beaker, and so we're just going to copy that down. We're not going to do anything to it. This one's also aqueous, so again, we're going to separate it into the individual ions. If you pay attention to these coefficients and to the subscripts in your formulas, as you write this down, you should end up with a balanced complete ionic reaction. Always a good idea to check. So from that balanced sorry, from the complete ionic equation, what we're going to do is we're going to cross out any of the ions that didn't get involved in a relationship. We call those spectator ions, because they were hanging around watching stuff happen, but they didn't get involved, right? So here, nitrate, there are 2 nitrate ions before all of this mixing occurs, and afterward there are still 2 nitrate ions. Nitrate ion didn't undergo any chemical change, and so we're just going to cross that guy off as a spectator ion. So those guys. And then potassium ions, also nothing happened to them, so we cross those guys out. And what we have left are lead and chloride as the reactants and PbCl2 solid as the product. And so lead and chloride are the 2 ions that got into a relationship in this beaker, right? They formed an insoluble compound. A chemical reaction happened for them, but not for the other guys. Any questions? So let's practice this. Consider the following reaction occurring in aqueous solution. Write the complete ionic and net ionic equations for this reaction. So we are given the molecular equation. So we learned how to predict that and balance that and everything. So here, that part's been done for us. We're going to write the complete ionic equation, and we're going to do that by looking at anything that's aqueous, and then, except for weak acids, we're going to separate those into ions. One of these days I'm going to fix this. This is an acid. It's aqueous, but we have not learned which ones are strong and weak yet. The book is like a couple pages over. So these are the strong acids. There's only 6 of them. Any other acids are weak acids. So those are the 6 strong acids. So we see this first one, that's an acid. So we have to ask ourselves, well, is it a strong acid or a weak acid? Because if it's a weak acid, it's mostly intact molecules. If it's a strong acid, it's definitely ionized into separate ions. So this is one of the strong acids, and so I'm going to write this as the individual ions. Yes?
To memorize that.
You should memorize those, yeah. So HI, we have to be able to write the individual ions that form, right? So we've got hydrogen, and these ions are going to be aqueous, and we've got iodide. And then looking at this, it's a 1-to-1 ratio of hydrogen to iodide, and I have 2 of these units. So that means I have two hydrogen ions and 2 iodide ions. The next compound, this is ionic, it's got a metal in it. This is also aqueous, so we're going to separate this into individual ions. So this is going to be barium ion and hydroxide ion. And how many hydroxide ions are there going to be? There's going to be 2 of them. For every 1 barium, there's going to be 2 hydroxides. So I need a coefficient of 2 there. Over here on the product side, this is water. This is a liquid. Solids, liquids, and gases, you just copy them down. You don't do anything to them. So this one just can be H2O, liquid. And then here we have another aqueous ionic compound that we need to separate into ions. So that's going to be barium ion and 2 iodide ions. Now, sometimes I'll see someone split this into ions, and they'll call this Ba2 plus and I2 2 minus. Well, I understand why you might want to do that, right? But the 2 here means that I have 2 of the iodide ions, right? So you need to watch out for that a little bit, because that's not correct. So that's my net ionic equation, and we'll sometimes call that NIE for net ionic equation. I'm sorry, that's not the net ionic equation. This is the complete ionic equation, CIE. And then to write the net ionic equation, we're going to cross off the spectator ions, the things that are the same on both sides of the arrow. Can you name one of them? The iodide, right? So I've got 2 iodides here, and I've got 2 iodides over here on the other side. And barium. I have barium on this side, and I have barium over there. They didn't get involved. They are the same after the reaction occurs. So those are the spectator ions, and we're just going to leave them out. And then we're going to copy down what's left. And this will be my net ionic equation. So 2 hydrogen ions plus 2 hydroxide ions is going to give me 2 water molecules. Now, if this is a mastering chemistry problem and you type that in for the net ionic equation, it might tell you you're wrong. A proper chemical equation has the throwing my pencil away has the lowest ratio of coefficients. These coefficients are all 2. So I could divide all the coefficients by 2, and I'd still have the same relationship. And so that's the best answer. I'm not going to try to trick you with that on an exam or anything, but mastering chemistry, they can be kind of mean sometimes. Any questions?